Good morning, students. Welcome to KUTV Elim Live. Today is Tuesday, Mathematics for Secondary School Students. Welcome. I'm your teacher, Mr. Ndenga-Elphas. And in our lesson today, we are going to discuss one aspect that was raised by one of you, a student from Kitui High School, Peter Mwema. And his concern is based on the use of mathematical tables. And that is what I've prepared to discuss with students in our today's lesson. So we are discussing the use of mathematical table. The use of mathematical table is a very crucial area in high school when it comes to use of different topics. And this mathematical table is actually taught from Form 1. And it's a requirement by the Kenya National Examination Council that when you are sitting for your KCSE exams, you must have or you should be in possession of the required 4-figure elementary mathematical table that is approved by the Examination Council. And therefore, it's a requirement that as a student in high school, when you are learning mathematics, you ought to understand the use of mathematical tables. Right from Form 1, in topic 9, we are taught something we call squares and square roots. That is the first topic that teaches how to use a mathematical table, and it lays the foundation for all the subsequent topics that require the use of mathematical table. If you open this mathematical table, you'll realize right from page 1 to page 37, it has different aspects covered in mathematics. Some of them are also covered in physics and other science subjects. But the respective columns are covered under different topics. So in our lesson today, we are going to look at the aspects that are covered in Form 1, topic 9, that is squares and square roots. We'll look at the aspects that are covered in Form 2, topic 1, that is cubes and cube roots. We shall look at the aspects that are covered in topic 2, Form 2, that is reciprocals. And lastly, we shall look at few areas that are covered in topic 3, Form 2, that is logarithms. So, having said that, I believe my students, you are now have gotten where your table was, and we are ready to discuss the use of mathematical table. In each and every area under the use of mathematical table, students are directed to topic number 8 in Form 1, where we teach you something we call standard form. The standard form aspect or concept is key for you to be able to read anything in this mathematical table. And so even as we start, I want to believe we are aware of how to write the numbers in standard form. Now, to discuss the use of mathematical table, since it covers a wide area and many topics are involved, I'm going to use few questions to illustrate what is done in each one of the topics. And then from there, I will give a combined questions. So the areas covered under the use of tables in our lesson will be what we call squares and square roots. Squares and square roots. This one is taught in Form 1. This is taught in Form 1. Number 2, we have the aspects on cubes. The topic itself is cubes and cube roots. But now, in terms of use of tables, we shall look at cubes because the syllabus does not provide the use of cube roots for high school students. So we shall look at cubes, and that is covered in Form 2. Number 3, we shall have an aspect on reciprocals. This is covered in Form 2. And then number 4, we shall have an aspect on logarithms that is covered again in Form 2. That does not mean that these are the only areas that require the use of tables. For Form 3s and Form 4s, we will be able to tell that we also have the aspects on trigonometry that requires the use of mathematical tables by reading those columns of sine, cosine, and tangent. But now for our lesson, let's be able to concentrate on these 4 areas. Now, starting with squares. How do we read squares of numbers from tables? How do you read squares of numbers from tables? It is a very simple aspect. When you are reading the squares of numbers in tables, the first thing is always to write the number in standard form. Write the number in standard form. You write the number in standard form, and a general form of numbers in standard form is a times 10 raised to the power n. And we will see the power n and what is the value for a. But just to remind you, there are 2 conditions for a number to be in standard form. The number 1 is that you must have a decimal point between the first and the second digit, and that first digit must not be 0. Then that number will be in standard form. Number 2, we shall find the square of a from tables. We shall read the squares of a from tables, and we'll find again 10 power n raised to 2, which means the square of 10 power n. And as a Form 1, you know that 10 power n squared means 10 power n times 10 power n. So you do it twice. For a Form 2, a Form 3, and Form 4, he or she will not take this process, but rather will apply the laws of indices. We have the third law of indices, power of power law. When you have 2 powers, then it simply gives you 10 power 2n. So whether we are talking to Form 1s, we'll use this approach, and when we discuss with Form 2s, Form 3s, and 4, we'll use the second approach. Both of them are the same, and they will give you the same answer. So let's see. If we have to look at a case, of a question, where you're told to find the square of 0.0692 using mathematical table. We find the square of 0.0692 using your mathematical table. So now, Form 1s who are in our class, we've given you the procedure for getting the square of the numbers. We shall write this number in standard form. That is what the steps we have written indicates. And what is a number in standard form? A number is in standard form when the decimal point is between the first and the second digit, and that first digit must not be 0. So by fact that 0 here is the first digit, and we are disqualifying 0 as being the first digit, we have to move the decimal between 6 and 9. So we have 6.92 times, now we have the aspect of times 10. Then we have to tell what is n. N is simply the number of steps you move the decimal from the new position where you've placed it back to the initial position it was. So I'm moving 1, 2 steps to take the decimal point back to its position. And since we are going to the negative side, it becomes -2. Then what do? The question is square. So we take 6.92 squared times 10 power -2 squared. We shall read this from the table. So we shall read 6.92 from tables. We shall read 6.92 from tables. So my students, can we now turn to the columns for squares? And if you are using the 6th edition, which is the recommended edition as at now, then that should be on your page number 19. That is where we have squares, page number 19 of your mathematical table. And for those who don't know, you need to understand that when you're reading squares of numbers from tables, we have 3 columns in the mathematical table. We have the first column, which we call the X column. We have the main column, or the middle column. The middle column is numbered 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then we have the addition column, simply written add, which has 1, 2, 3, 4, 5, 6, 7, 8, and 9. And this is why this table is referred to as the 4-figure, because it only gives us the opportunity to read to a maximum of 4 significant figures. And so why do we write the number in standard form? It's simply to give us the values for x. The first 2 digits are identified under the X column. So in the square column, identify 6.9. Identify 6.9. So we should be moving together. 6.9. Remember, we are on page 19 of the 6th edition. Page 19 of the 6th edition. That should now be on page 20. 6.9 is on page 20. And then we are going to the 3rd digit, which is determined in the middle column. That should be under 2. So under 2, there is a value. Under this column for 2, there is a value, which is 6.92. That is 47.89. That is what is written under 2. So it means the square of 6.92 from the mathematical table is 47.89. So we write it here, 47.89. Then we multiply by 10 power -2 squared. And we are agreeing that 10 power -2 is 10 power -4. You simply take -2 times 2 to get -4. And so when you have a negative number, negative power, we are moving the decimal point 4 steps to the left. So this is 1, 2, 3, and 4. So now the value will be 0.004789. And that is our solution. When you're looking this from the tables, remember what we have on the board is a 3 significant figure. We could have 4, assuming we had 6.925. Then what we are allowed to do is, once we've identified 47.2, this 4th digit is determined in the addition column. So you come to what is in the addition column, assuming it was 6.925. In the addition column, the table has under 5, it has 7. So if that was the case, then we will take 47.89 and then we add 7, which is in the addition column, so that this gives us 6, 9, 7, and 4 as our solution. So that is one way, one thing that I want us to remind ourselves, the use of square table. It is as simple as it is. Number 2, still in Form 1, we need to review again what we call square roots. Square roots. The understanding of square roots is built from squares. And what you do when you're reading the tables of square roots is, 1, to write the number in standard form. Write the number in standard form. Write the number in standard form, i.e. a times 10 power n. But we shall do some difference in terms of the power. We have to ensure the power n must be even. It must be an even power. And that explains as to why square roots in the mathematical table are divided into 2 parts. We have the square roots for numbers that are between 1 and 10, and the numbers between 10 and 100. It is because we have to know that as much as we are saying the condition for you to read the mathematical table is based on you writing the number in standard form first, there comes a time when we shall have to change that rule so that we have the power of n being an even number, so that you can be able to read in the correct column. The moment you write the power that is not even, you will read in the wrong column and you will get the wrong answer. So ensure the power you're using in square root is even. We shall then find the square root. We shall find the square root of a from tables, and find 10 power n raised to 1 over 2. Now you should be able to know again that when you raise a number to the power that is a half, then it means you are finding the square root of that number. So in this case, unlike in squares where we multiply by the power, then what we shall do here will be 10 power n over 2. We divide n by 2. Those are the steps that we follow when we are discussing square roots. To illustrate this, this is the question. Use square root tables to evaluate 0.7346, and then after that I want us to do the comparison when we have 8.412. In the first case, we are finding the square root of 0.7346. I've explained, for you to get the square root from tables, write the number in standard form. In the normal circumstances, 0.7346 in standard form will be 7.346 times 10 power negative 1. That will be the normal way of writing this number in standard form, which is right. If we were using other columns, let's say squares, cubes, logarithms, we will be allowed to use it as it is. But now in square roots, we are changing that logic because the power n must be an even number, and negative 1 is not even. So we change it to be even by moving one more step ahead. So I'll move the decimal from between 7 and 3 and put it between 3 and 4. And once I do that, then the power changes again to negative 2. And so that becomes the right form of this number in standard form for the use of square root tables. Now this tells you then 73 is between 10 and 100. So we shall go to identify it between the numbers which are between 10 and 100. So if you open your mathematical table, turn to your mathematical table between 10 and 100, that is from page 23 to page 24 of your mathematical table. Again, square roots, just like squares, they have the same columns. We have the main column with the x column, and then we have the addition column. We have the main, the x, and the addition column. So look at the square roots and check where we have 73 in the x column. That's on page 24, 73. Under x, identify 73. And then go for the main column where there is 4. Where there is 4 in your columns, that is under 4, we have 56, 74. 56, 74. That is covered under 4. But remember, unlike in the columns for squares, in square roots, we are not given the decimal points in the main column. But the first value before the decimal point is captured in the first case where we have 0.0. So if you check at this first point of every column, of every digit in the square root column, you'll find the first number to start with. So in this 73, under 73, all the values are starting with 8 points, if you check from your tables. So it means 73.4 should give us 8.5674. That is what is in the column. But there is one digit more, that is 6, which is now found under the addition column. So you move along the same column until where you have 6 in the addition column. If you move along that line, you find between below 6 we have 35. So the digit or the number here is 35. We are told to add. So what do we come and do? We add 35, from the right-hand side on this side. So this gives us 9, 0, 6, 5.8. Then now times 10 power negative 2. We raise it to 1 over 2 because we have to find its square root as well. And we've said these two cancel out, so this is negative 1. And so the solution is 8.5609 times 10 power negative 1. Negative 1 means we move one step to the left, so that is 0.85609. And that is the solution. We've seen how we'll use the column between 10 and 100. Now let's do the comparison between what we have in A and what we have in B. Part B, we shall again write the number in standard form. So 8.412 times 10 power 0, because that number is already in standard form. So we are not moving the decimal in any direction. So it becomes times 10 power 0. We then go to read this number directly from the tables. And why are we reading directly? It's because our power 0 is an even number. So once it's an even number, we don't change anything. We read directly as it is. So we shall read 8.412 from tables. But from which columns? The column between 1 and 10. Because 8 is less than 10. So we shall read this from numbers between 1 and 10. So then turn to your mathematical table. Turn to your mathematical table. And from page 21 to page 22, that's where you have between 1 and 10. So 8.4. 8.4 under the X column. Identify 8.4. 8.4. And then move with that up to the main column where there is 1. So below 1, we have 9,000. At this point, we have 9,000. .41, that is 9,000. And at this point for 0, all the numbers here are starting with 2. So the numbers are starting with 2. Therefore, it means 8.4, reading 8.41 in the table gives us 2.9000. And students, if the question is use mathematical table, I know some of you will take out your calculators, press them in your calculators and write the answer. You will get the correct answer. But at some point you shall get to understand that what the table gives is not what the calculator gives. The calculator will give without these 3 zeros because they will be termed insignificant. But the table will still give you the zeros. So if I realize your answer is 2.9, then I will know this is a victim of people who would not use the mathematical table. So we have 2.9000 and move along the same line to where there is 2 in the addition column. So you move along the same line to where there is 2. Where there is 2, we have 8.4, there is 2, we have 3. So the column has 3. So we come to add 3. We add 3 here, so that we have 3009.2. And that becomes the square root of 8.412. So that is area number 2, square roots. And as I told you before, squares and square roots are covered in Form 1. So that was a reminder to the Form 2, 3, and 4, and as well as to the Form 1 on square roots. Once you get to Form 2, Topic 1, we talk about cubes and cube roots. The topic is cubes and cube roots, but the only aspect that is taught for the use of tables is what we call cubes. In cubes, we follow the same procedure. Ensure the number is in standard form. Write the number in standard form. i.e. a times 10 power n. Once you've written the number in standard form, you simply find the cube of a from tables and find 10 power n cubed. And again, because topic 1 is before indices, the steps will be 10 power n cubed means 10 times n, 10 times n, 10 times n, 3 times. But after learning cubes, indices, you simply take this as 10, then multiply 3 by n to have 3n. Whichever level you are in, whether you are before indices or you are after indices, that's how you work out cubes of numbers. There is no change in the way we read cubes from the way we read squares. And so cubes covered on page number 25 of your mathematical table. Cubes are covered on page number 25 of your mathematical table. And so we shall take one question to illustrate this. We are told to use tables to find the cube of 24.6. Find the cube of 24.6. Use tables to find the cubes of 24.6. The way columns of cubes have been drawn is the same as the columns for squares and square roots. So we'll still apply the same interpretation we've made here in reading the value for the cube of 24.6. First thing first, number in standard form. So now we've been able to write cubes and squares and square roots. Let's write 24.6 in standard form. 2.46 times 10 power 1. 2.46 times 10 power 1. We are finding cube, so we have 2.46 cubed times 10 power 1 cubed. We read this one from the table. So let's turn to our cubes column and identify 2.4. So if you check your table, under X, identify 2.4 in the cubes and move up to where there is 6 in the third column. So below 6, where there is 6, you'll find the value in the mathematical table is 14.887. 14.887. So you take that value and write it here. 14.887 times 10. So we multiply 1 by 3, power 3. That is positive 3. So it means you move the decimal 3 steps to the right. So it will move 1, 2, and 3. So your solution becomes 14.887. Sorry, 14.887 because the decimal has moved 3 steps to the right. That is the cube of 24.6 from mathematical table. Lastly, for today, we have to look at reciprocals. We will look at reciprocals. Reciprocal is covered in Form 2. It's a very short topic. in form 2. And for reciprocals, I will want you to know that when you're using reciprocal tables, there is always a change on the table on the last column. Other columns provide add, but reciprocals provide subtract. So that is what we shall be doing in the last column. In the previous columns, we've been adding, but here we are going to subtract in the reciprocal column. Reciprocal columns in your mathematical table, that's the 6th edition, should be found on page 17 to 18. Page 17 to 18 of your mathematical table provides reciprocals. Now, for this case, I want students to know one thing, that we have two ways of determining reciprocals, or two cases rather, of determining reciprocals of numbers. In the first case, we have simply a number whose numerator is 1. And number 2, fractions whose numerator is more than 1. Both cases will require a different way of handling the denominator in determining the reciprocals. But in common, for all the tables, we are saying the first thing that we shall be doing here, again, will be to write the number in standard form. Write the number in standard form. And therefore, it means you cannot use the mathematical table unless you know how to write the number in standard form. And that is why this concept is taught in Form 1 under decimal, so that you get ready of knowing how to write the numbers in standard form, and that will help you to know how to read the mathematical table. So unless you know how to write the number in standard form, taking this mathematical table will be a bit difficult. But it is a very simple concept. So the number will be a times 10 power n. In reciprocals, we are going to read the value for a. Read the reciprocal of a from tables. And for 10 power n, change the sign. Change the sign of n. It is a very simple way of understanding reciprocal, because if I'm to go to the longest method of how that becomes true, then I have to apply indices, I have to apply division. But the simplest way to get it is, once you've written the number in standard form, read that value from the table, and then for this 10 power n, change the sign. If it is power negative 1, it turns to power positive 1. Power positive 2 turns to power negative 2, and so on. Let's see the question. Use reciprocal tables to find 1 over, no, let's write directly, 0.482. Then I will compare it this way with 2 over 0.635. We have 0.482 and 2 over 0.635. To work out the first one, you must know what's the meaning of reciprocals. Reciprocals of numbers is simply 1 over that number. So the reciprocal of this number, it technically means 1 over 0.482. That's the reciprocal of that number. So express this number in standard form, you will have 4.82 times 10 power negative 1. So for reciprocals, we are saying, read this from tables. We read 4.82 from reciprocal tables, and then we shall multiply by 10 power positive 1. You change the sign. Then multiply by 10 positive 1. That is the meaning of changing the sign of n in reciprocals. So turn to a page number 17 and identify 4.8 in the x column, and move below 2. You find the value is 2075. All reciprocals except for 1.0, all numbers or reciprocal of numbers except for 1.0 starts with 0. Therefore, it implies that this is 0.2075. 0.2075 times 10 power positive 1, and this means is 2.075. That is the solution. Part B, you're told to use reciprocals. And for this case, do not find yourself reading the reciprocal of 2 from tables. It is unnecessary. When you have 2 over 0.635, to find the reciprocal of this number, you simply rewrite this number to 2 into 1 over 0.635. In simpler terms, when you have a fraction whose numerator is more than 1, then to find the reciprocal, simply find the reciprocal of the denominator and multiply it by the numerator. So we find the reciprocal of 0.635. The answer we get, we multiply it by 2. Then we shall have found the reciprocal of the whole of this number. So 0.635 to become 6.35 times 10 power negative 1. And then what you get here, we shall multiply it by 2. So 6.35 from reciprocal tables. We read 6.35 from reciprocal tables. So it will be on your page number 18, 6.3, 6.35. That is 1575. So 0.1575. Then we change the sign times 10 power 1. And so that becomes 1.575. Then we multiply it by 2 because the numerator was 2. So I will have 1.575 times 2 to get 3.15. That is how we use the tables for reciprocals. Now, we may not be able to finish all the tables because we have a lot, especially when looking at logarithms. And so that will be the last column that we are discussing. But there is a question that I want us now to do as we end our lesson. And the question was posted by, as I said before, by a student by the name Peter Mwema from Kitui High School. His understanding was based on the use of mathematical table to evaluate a question. And this was the question. I told to use square roots, no, evaluate using square roots, squares, and reciprocal tables. And we had 2 over the square root of 0.7359 minus 0.3975 squared. So wherever you are watching us from, Peter Mwema, this is now your question. And I hope by the end of the lesson, you and many who had a challenge in the use of tables will be able to know what is done. Now, students will read this and say, we are using square roots. So they will identify very fast that this one requires the use of square roots. Squares, they identify this requires the use of squares. And then they are left wondering, where is the reciprocals? Reciprocals comes at a point where you find there is a fraction. So at this point, we have 2 things to work out. We have the square roots, and then we have the reciprocals at the same point. So you must identify which one comes first. And the square root will come first, evaluate the square root of this number, then now replace it back and find now the reciprocal. Then we will now work out the squares. Such kind of a question has 2 sides. With the left-hand side, which has 2 over the square root of 0.7359. So the first thing to do, find the square root of 0.3759. So we'll write the square root of 0.7359. Standard form, 7.359 times 10 power negative 1. But we've said in square roots, this will have to change. So we shall move one more step so that we now use the number 73.59 times 10 power negative 2. And find the square root. So we shall read the square root of 73.59 from tables. We'll read the square root of 73.59 from tables. So to our square root tables, our square root columns, that is now, the number is between 10 and 100. So turn to page 23 onwards, specifically page 24, and check 73 in the X column. Identify 73 in the X column. Then go up to where there is 5. Below 5, you've 5732. 5732. And move along the same path to where there is 9 in the addition column, and you find 53. So you add 53. This is 5, 8, 7, 5, 8. Then times 10 power negative 2. What do? We raise it to a half, so this cancel negative 1. And so the square root is 0.85785. That is the square root of 0.7359. Then I now rewrite it and say 2 over now 0.85785. So this now takes us to reciprocals. So we find the reciprocal 2 into 1 over 0.85785. So we shall get the reciprocal of the denominator, and then we multiply it by the numerator. If you count these digits, this is 1, 2, 3, 4, 5. There are 5 significant figures. But our mathematical table gives to 4 significant figures, so you have to round off to 4 significant figures. And so that will mean we round off this to make it 9. 5 can round off 8 to 9. So it will be 8.5789 times 10 power negative 1. That is in standard form. Then the solution that we get this one, we will multiply this one by 2. So we read the reciprocal. The reciprocal of 8.57, that is 8.579. This is 9. 8.579 from tables. So we'll go to reciprocal columns, page 17. That should be 19. 8.57. That is 1167. Then below 9 is 1. So 1168. So 0.1168 times 10 power 1, then times 2. So if you have your calculators with you, this will be 0.1168 times 10 times 2 to get 2.336. So we shall have worked out the left-hand side. And finally, we look at the last part, which has the square. For the square, we have 0.3975 squared. Standard form, 3.975 times 10 power negative 1, then we square. So we read 3.975 from squares. 3.9. Check from your page number 19. 3.97. That is 15,761. Then move with the same line to where you have 5. Below 5, you have 39. 39, so we add, this is 0, 0, 8, 5, 1. So you have 15.800 times 10 power negative 2, that is 0.15800. And so finally, the question is, we take what we have on the left side, which is 2.336 minus 0.15800. You do that subtraction, 0.15800, you get the answer is 2.178. And that is the solution for that question. I believe with that now, you are ready to work out anything you'll be asked from the use of tables regarding squares, square roots, cubes, and reciprocals. Next time, we shall be able to look at the other columns. That will be in our next lesson. Thank you for being part of our lesson today. Until we meet next time.